Hello everybody. Today's lecture is going to be on the predicted effects of global warming. And as you can imagine, this is not going to be a pleasant list to go through. And so I could have really said that today's lecture is a lot like the dentist drill. It feels so good when it stops. Let's get started. The first thing is severe drought is likely to increase, and in fact, we already know that NASA scientists have seen that there is an increase in the number of global droughts in the last decade or two. The effect of drought, of course, you could probably imagine many of them, but here are just some of them. Increased wildfires, and we have seen that. There's a lot of indication that that is happening. The fires in California and Arizona in the last 5 years in particular come to mind. The declining flow of streams, rivers, the lowering of water tables, the water we take our groundwater from, and the drying up of lakes, the drying of lake beds. All of these are examples that might happen from drought. The other thing is that dry climate ecosystems will increase, and we often call this desertification. When I first heard about desertification, I thought it was great. Everybody was going to get more desert. But no, what it means is that the dryland ecosystems are increasing in size and decreasing in productivity. And then there will be less drinking water in certain areas. These are all effects of drought. And it's interesting because many of these effects decrease the rate of CO2 uptake by plants because they decrease plant growth. And so this would be another positive feedback loop. Increasing drought decreases plant productivity, which means that less CO2 is taken out of the atmosphere. That means there's more CO2 in the atmosphere, which leads to more drought, etc., etc. I think you get the idea. In addition, more ice and snow are likely to melt, particularly in glaciers. Global warming is already worse in the polar regions. And one of the reasons for that is the feedback loop that happens when dark land is uncovered, and the dark land absorbs more energy instead of reflecting the sunlight, and therefore it becomes warmer than it normally would be, which means it doesn't get as cold in the winter, etc., etc. Another positive feedback loop. Glaciers are shrinking. We saw the evidence of that. And here's a new fact. 99% of Alaska's glaciers are already shrinking. I'm surprised that's not 100%, and maybe at this point, because that statistic is about 10 years old. The problem with mountain glaciers disappearing is there's far less water in many major rivers upon which people depend, and that will cause problems. The glaciers are already diminishing in the Himalayas, the Alps, the Andes, and in Greenland. So there's another issue that we already know about. Another problem, permafrost is likely to melt. What in God's name is permafrost, you might ask? And why would that be dangerous? So permafrost is the frozen layer of soil in the Arctic that stays permanently frozen, permafrost, even during the growing season. So in the Arctic, the permafrost is down maybe 6 to 10 inches, and then above it is a thawed layer in which all the plants grow, in which all the biological activity happens. And the problem is, the permafrost in the Arctic, not only does it define the tundra biome because it doesn't allow trees to grow because their roots would be permanently frozen, but the permafrost contains huge amounts of methane. One estimate is that it's 50 to 60 times the current annual carbon dioxide emissions from burning fuels. And don't forget that methane is a more potent and longer lasting greenhouse gas than carbon dioxide. There is also methane in the permafrost on the Arctic seafloor, and we have much less of a handle of how much of that there is. But as the Arctic Ocean gets warmer, we will expect more of that methane to go into the atmosphere. Another positive feedback mechanism. Here then is a map of the effect of permafrost loss on the tundra biome. And you can see on the left, the current map of tundra is shown by the white area on the map. And then predicted for the end of this century is what would be left of the tundra biome. So the tundra biome will also be lost. Sea level rise, pretty self-explanatory, but as we said earlier, when glaciers melt, when land-based glaciers melt, they're going to cause sea level to rise. The prediction is that by 2100, sea level will rise by 0.8 to 2 meters. If you want to know how big that is, well, 0.8 meters is about to here, and 2 meters is about to here. Can you see that? Probably not. Well, I'm pointing over my head. Now, some climate change deniers have pointed out that melting ice in a glass of water does not cause the water level to rise in the glass, and that is true. However, on Earth, sea level rises for two reasons. One is the melting of land-based glaciers, which I have put here as 2, just to confuse you. And 2 is that warm water actually expands. It increases its volume. The most recent data suggests that about half of sea level rise will be due to thermal expansion of the water, and half will be due to the increased water in the ocean from melted land-based glaciers. Now, if sea level rises, here's what's going to happen. 1, about a third of all coastal estuaries, wetlands, and coral reefs will be degraded just from sea level rise. Let's not forget the effect of warming on corals. Another one, all these coastal fisheries will now be disrupted, and nobody is really sure what will happen to them. But rapid change in an ecosystem usually does not improve productivity, but rather has a detrimental effect. Flooding. Low-lying barrier areas and coastal areas will now become flooded on a more regular basis. And we're already seeing this up and down the eastern seaboard of the United States, where people who live in coastal areas deal with flooding on a much more regular basis. Agricultural lowlands, particularly, for example, on the eastern shore, will be flooded, and in deltas and river deltas will be flooded. And the question is how much damage that will do. Everybody's predicting that it will do considerable damage. Coastal freshwater aquifers, don't forget, aquifers are underground reservoirs of fresh water. Coastal aquifers will now be contaminated with salt, and there will be several low-lying islands in the Pacific Ocean, the Indian Ocean, and the Caribbean that will become so flooded that they will have to be abandoned partially or completely because of the rise in sea level. So I'm going to show you some of the effects of this right now. Here's one. Here's a map of Florida, and you can see that the complete outline is what Florida looks like currently, and the red is what is predicted to be lost from Florida in the next century if sea level rises as it is predicted to do. So I would recommend you visit Miami soon because it's going to be flooded. And here is a picture from the Maldives in the Indian Ocean, and we will read a news story in class about what the people of the Maldives have done to prepare for climate change. Okay, next. Extreme weather is likely to increase. A warmer Earth holds more atmospheric moisture, and one surprising prediction of that is that while there will be more rain, which is logical, if there's more moisture in the air, there's more to fall, there will also be more droughts. And what this means is that some areas will get more rain and other areas will get less rain. If some areas get more rain, the prediction is that it is going to come from more intense storms, and more intense storms cause more damage. At the same time, heat waves and droughts are going to increase in other areas, and these are likely to increase mortality. Are storms already getting worse? And the answer is yes. We have theoretical studies, such as the one by Saunders and Lee from 2008 cited here, that shows that since 1950, for every 0.8 degrees C increase in Atlantic Ocean temperature, there are 33% more hurricanes and 45% more intense storms, and this has been supported by other data. And the World Meteorological Association predicts fewer but more intense storms. So far, that prediction has been wrong in the fewer part, but correct in the more intense storms part. Climate disruption is going to present a big threat to biodiversity. A paper in 2009 suggested that if the warming continues as predicted to the end of the century, that it could cause a loss of up to 85% of the Amazon rainforest area. The IPCC in 1997 predicted that 30% of the species on Earth would be lost with a 2.5 degree rise in temperature, and 70% with a 3-degree rise in temperature. We've already talked about how coral reefs would disappear, and currently we know about 35,000 to 60,000 species that are associated with coral reefs, but it is estimated that the actual number is between 1 and 9 million species. And these, of course, these species, this biodiversity resource, this genetic library, and we'll discuss these ideas later in the year, they would then be at risk of disappearing. Mountaintops often serve as refuges for certain communities, increasing biodiversity, and also they serve as areas of speciation. And these remnant communities are already being lost and would continue to be lost with global warming. And finally, we expect that warmer temperatures will cause all sorts of ecological disruption. One example of that is the outbreak of lodgepole beetles, which have damaged more than 60% of the forest in Colorado. And look what it looks like. Here it is, right? I was there in 2015. It's amazing. You'll see these mountains, and when you look carefully, you'll realize that 50, 60, 70, in some cases 100% of the pine trees are dead on the side of the mountain. And it's all due to the lodgepole beetle. So what's the lodgepole beetle story? It's also called the mountain pine beetle. Two biologists have discovered that the mountain pine beetle now reproduces twice a year because it's warm enough for them to do so, whereas before they would only reproduce once a year. This means they have bigger populations. So the temperatures have been increasing over the last 40 years, and especially in the spring, which allows these beetles to get an early foothold and produce that second generation. They start their flight season more than a month earlier and fly more than twice as long. When the adult beetles emerge in late spring, they lay eggs on lodgepole pine. Those early eggs develop more quickly through the summer to produce adults that emerge in August. This summer generation had never been reported for the species of beetle. Faster development in 2 generations means the population is at least 10 times larger than any times in the past. It now kills trees 450 miles farther north and 200 feet higher in the mountains than it did historically when mortality was much lower. And now mortality has increased and is much more widespread. Next, we look at agriculture. As the climate warms up, the regions best suited for agriculture will shift as rainfall patterns shift. Here are some of the problems. Tropical and subtropical areas are predicted to have an actual decrease in productivity. And since they're some of the poorest areas in the world, that does not bode well. There's predicted to be an increase in productivity in continental climates. However, continental climate areas have poorer soils, less inherently fertile soils, and it is thought that as a result, total food production could start to drop. This entire area of agriculture and climate change is still poorly understood, but it is interesting to note that agriculture has been a contributing factor in climate change. In 2006, the UNFAO, the Food and Agriculture Organization, said that 33% of the global warming since 1960 can be blamed on agriculture. And why is that? Can you guess? Well, if you said that agriculture is energy intensive, fertilizers and machinery require the consumption of a lot of fossil fuels, then you're right. Give yourself a pat on the back. Okay, so those are the big effects. Now we're going to summarize them for you, just to go through them quickly. All of the following are likely to happen with enough increase in temperature. Ecosystems will change and collapse. Low-lying cities will be flooded. Wildfires will increase, especially in forest ecosystems. There will be more prolonged droughts around the world. There will be more destructive storms. Glaciers will be shrinking and rivers will dry up. Extinction of up to half the world's species, and some people now are predicting more. And we'll talk about the 6th extinction later on when we get to biodiversity. There will be the spread of tropical infectious diseases away from the equatorial regions. And finally, I give you these tables that were compiled from our textbook. What is likely to happen at 2, 3, and 4 degrees increase in temperature? You can look at these on your own time and see what you think about them. Okay, so I think that's going to do it for us today. As I said, I don't think that was a pleasant set of things to listen to, and it is truly frightening, I agree. And one could tend to feel a little pessimistic and that it's a really difficult and intractable problem. But we've already begun looking in the class at some of the things that could be done. So in the next class, we're going to talk about some of the things that could be done. Until next time, study hard.